I will disappoint everybody by saying from the start, I have no slides. You will have to look at my pretty face or my terminal most of the time. No slides today. Anyways, so my name is Viktor. I work for Codefresh. I'm not sure what I exactly do because I'm kind of mixed between many different roles, from product management to developer relations to being a developer. It's myself, architect. I don't know. I do stuff. I have some books, some courses, some webinars like this with you guys, and so on and so forth. But what matters more than who I am and stuff like that is what we're going to talk about. And what we're going to talk about is my obsession to automate myself out of my job. And that means full automation of almost everything that we can do. And today specifically, I'm going to try to show you one potential way how to do continuous delivery. And by continuous delivery, I mean everything automated from pushing a change to a Git repository all the way until it is either releasable to production, which would be continuous delivery, or until it is running in production. I don't want to see any of you in any step of that process. I don't want to see humans over there. People are good at being creative. They're horrible at doing repetitive tasks. So out with humans, let's say. That could be the title of this. So what do I want to do? I want to automate everything from the beginning to the end. I want to make it safe. And by making safe, I mean making it secure. I want my users to have best possible experience with the product that is going through that process, while it's going through that process, and after and before and all that stuff. So a couple of important things of what I will try to do is, first, I will try to remove humans from the process, meaning that I need something to orchestrate my pipelines, the steps of life cycle of my application. I will try to make things as generic as possible so that you could apply those things to many different tools depending on what you're using. Still, I will have to use some tools, and for continuous delivery, I will use Codefresh. Codefresh will be running pipelines that will automate stuff. I want everything that I do to be traceable, meaning that everybody in my team, in my company, wherever, should be able to know at any given moment what is the desired state of any part of my system. And for that, I will be applying GitOps principles. If you're not familiar with what GitOps is, then you should be. You should feel ashamed. And so I will explain it just briefly. And that is that GitOps is acknowledgement that everything we do is defined as code. And code is always stored in Git. And therefore, code is in Git. And that means that Git is the source of truth. Git defines 100% the desired state of what our systems should be. And I'm intentionally saying desired state because desired state might not necessarily always be the same as the actual state, but we are trying to make those two types of states as much the same as possible. I want it to be safe, and to accomplish that, I don't think that anybody should have access to my cluster. I shouldn't have access to my cluster. You shouldn't have access to my cluster. And even the tools I will be using will not have access to my cluster. Nobody can access the cluster. That's the safest way to do it. Now, in the past, nobody or very few can access the cluster meant that everybody else had to suffer by waiting days, weeks, months until something happens, right? To open 75 Jira tickets. No, that's definitely not what I'm trying to do. I try to remove any application or any external application, tool, human, person, to have access to the cloud cluster without sacrificing productivity in any form of way. If anything, I wanted people to be more productive by not having access to the cluster. I also want everything to be scanned for security vulnerabilities, what's or not. So today I will use for that, actually, if I backtrack a bit, when I said GitOps, I will be using Argo CD. Still, everything I'm showing you equally applies to Flux. If you prefer Flux instead of Argo, later on we can discuss the differences. That's all good. So where was I? Yes, scanning, I will be using Snyk today. And finally, not finally, actually, there are at least two more things that I think are important in what I will try to do is I want to have reduced blast radius, meaning that if something goes wrong, I want only a fraction of my users to experience that until that something is fixed, right? So if I make a new release to production and there's something wrong with it, I don't want 100% of my users to see it. Maybe 5%, maybe 10%, maybe 20%, but definitely not everybody. So reducing the blast radius. So if bad things happen, they're affecting a reduced number of users always. And finally, if bad things happen and those things cannot be fixed by themselves, remember, no humans involved, I want the system to be intelligent enough to roll back to whatever was there before without me touching anything. Because remember, I have no access to the cluster. I cannot fix it even if I want to. Now, I will have the access to the cluster today, but mostly to show you what is happening behind the scenes. I will not change the desired state in any formal way. And for the reducing blast radius, doing some kind of iterative deployments and automating rollbacks and what's or not, today I will be using Argo rollouts. You could do something similar with, let's say, Flagger. There are other tools, right? Again, it's not really about specific tools. I'm using tools more to demonstrate certain principles than to tell you must use this or you must do. The only thing that you must use is Kubernetes, because come on, it's 2021 almost. There is no good reason not to use it unless you're having huge monolithic applications built to work in mainframe. But then you should change your job. What else? That's the introduction. That's what it will be a simple demo. So I will not do a real production setup because simply I don't have time to do a real production setup. A short demo, relatively short, with a simple application, but principles should apply equally to my simple demo as to huge real system used by zillions of users, what's or not. That's all. That's the introduction. That's the introduction without slides. And one more thing before I start. And that's that I want you to interrupt me as much as possible. People usually want to keep things for the end. If you have any questions, if you have anything you would like to ask or you want me to explain further or discuss, please do it right away. I will try to monitor your questions in the chat. I'm not sure whether you can interrupt me by voice. If you can, great. I like to be interrupted. So that's it. That's all I have to say before we jump into my terminal, and the rest will be very hands-on. Now, you probably know how this works. Hands-on things, demos fail always. So something will fail. Let's hope that it will not fail immediately. Let me share my screen. Ta-da-da, ta-da-da. So here I have my terminal. It's split into two parts. Ignore the right part. I will explain why I have it later, actually very soon. So I have my terminal. I have a Kubernetes. So what did I do before I started this? Not much. I created a cluster. I think that this is Azure AKS. I'm not sure. Anyway, I created a cluster. I already forgot what it is. It equally applies to any Kubernetes cluster. Does not matter. I have Kubernetes. I installed Argo CD. I installed Istio. Istio is a service mesh that will help us with progressive delivery and redirecting traffic, what's not. What else? And I installed Argo rollouts, and I deployed the first release of my application. And that's about it. Everything else will happen in front of your very eyes. Cool. So what do I have? Let me show you first my application. I will not bore you with the simple things that you already saw. I will just show you the definition of rollout, Argo rollouts, because that will be important for later. Not going into details unless you ask me questions. What matters for this definition are those queries over here, right? That if you're not familiar, this is by the way PromQL, Prometheus query language. It might sound scary. It's not really that scary. What I'm doing here is that I'm telling my application, look, apart from running and doing whatever we do with the applications, I want you to go and fetch metrics. And those metrics are based on some queries. And those queries are, in this case, average request duration. Sorry, this is the, let me double check what do I have here. This is the error rate. Give me all the services of this application, give me all the requests of this application that are that have response codes 200, meaning okay, and divided with all the requests in total, right? Very simple query. Gives me the error rate, how many of my requests are returning errors. And this one measures the average request duration. What is the, how much on average it takes to respond to some requests. And then I have some conditions, like success condition. If it's less than 1 second, 1000 milliseconds, then it's successful, considered successful. If it's more than 1 second, then it's bad. Now, I would never in production consider 1 second as being okay. It would probably be closer to 100 milliseconds on average or something like that. But anyway, this is a demo. And similarly with the error rate, I will consider it success if it's higher than 80%. Again, something that I will never do in production. In production, I would expect error rate to be closer to 99 point something. But hey, it's a demo. The rest is pretty standard Kubernetes stuff. I'm just deploying applications, application actually as a deployment with services and a bit of Istio. Nothing really terribly special about it. Now, let me show you also a few values that I'm using in application. And particularly, I want to show you this part here. This part here is saying, look, set the weight when you deploy a new application, set the weight to 10%. What that really means, start forwarding, start introducing that new release to 10% of your users. And while 90% at that time should continue using the old release. And then start measuring how those 10% behave. Are they having a positive experience or negative experience, and so on and so forth. And those measurements are based on the queries I showed you earlier, right? Measure the error rate, measure the request duration, and many, many other things which I'm not going to show you because, again, it's a simple demo. And then wait for 2 minutes. The reason I put 2 minutes here, for a demo, I would put it less, but normally approximately it takes up to 2 minutes for Prometheus to get sufficient amount of data that something there is to be measured, and then increase the rollout of the new release to 30% of users. Wait for 30 seconds, increase to 50%, wait to 30 seconds, and after that, all my users will see the new release. So I will be gradually showing new release to my users. And that's the blast radius that I was mentioning before. And all that, as I said before, is using, what is it using? Argo rollouts. Cool. Now, what do I have in a, let me show you what I have in a cluster right now. kubectl Argo rollouts, namespace is production. One also note that I did not mention, I will be going directly to production today, simply to save some time. You would be creating pull requests would be deployed to some preview environments, temporary environments. You would review pull requests, do whatever. Then you would merge it to the master and you would do the whole dance. I'm just jumping directly on the last part. So I want to see rollout of the application called DevOps Toolkit, DevOps Toolkit. And you can see that right now I have my application is running. It is healthy. And here it is, set weight, 100, right now 100% of my users are using this release of my application. That's the current state. Now, what I will do is make some change to my application. I will not really bother it with the code. So instead of making real changes to do code, I'm going to change something in the README, something, right? Just making a change so that I can push something to Git, otherwise Git wouldn't allow me to do that. And I will add those changes. I will commit those changes. I'm doing basically what every developer is doing. I'm making changes to the code or simulating changes to the code, I'm pushing to Git, and that's the only thing I'm going to do. Because remember, I have no access to a cluster. The only thing I can do, and I should do, is push something to Git. That's it. So commit, what will be the message? A silly change. Silly change. And I'm going to push those changes. Where was I? Yes. And I will go to my second terminal here, and I'm going to start sending requests to my application. And you will see that my application is responding with 402 with errors. And I'm doing that intentionally. I'm simulating what would happen if there is a problem with the release that I just made. And I made the release by pushing changes to Git, nothing else. Everything else is automated, right? Now, how is that everything else automated? I'm going to show you right now by opening my browser. And I'm going to Codefresh. The same applies to GitLab CI, to Jenkins, what's not. I just happen to use Codefresh because, well, I work for them. Otherwise, it would be weird. So what is happening is that when I push some changes to Git, a pipeline was started. Now, this is a very simple pipeline. I'm cloning the repository. I'm building let me make it bigger. I'm building my binaries. I'm building container image and pushing it to registry. I think it's Docker Hub. I'm not sure where I'm pushing it. And now I'm scanning it with Snyk. Now, normally, I would do more stuff. I would be running some tests and what's not, but I'm pretty sure that you know how those things work. So that should be fine. Now let's wait until this is scanned. And the right part actually is the part that is much more interesting. I'm going to get there. I'm just waiting for this. Actually, let me start explaining. Now, assuming that you want to deploy automatically, you want to do continuous delivery, you want to approve something and then deploy it to production, you're probably the first thought that most people have is that, okay, so in my pipelines, I should execute, I should SSH into a server and deploy something, or I should execute kubectl apply, or maybe helm install, or any of the ways how you do, how you execute stuff. Oh, this failed. Okay, this is now happening live. A few days ago when I tried this, this passed all the security checking, and now it's failing. And now it's failing. That means that there is a new vulnerability that happened between a few days ago and now. So this is how you know that I didn't try it today. I discovered a new vulnerability. Cool. Actually, you saw it live. It's not all scripted in advance. Yeah, so Snyk discovered new vulnerability. I should now go and fix it. But since this vulnerability is maybe in a base image, and I would probably need more than 3 minutes to fix it, I'm going to simulate that I fix that vulnerability by telling Snyk to actually ignore it. I'm going to do something that that if you do it in your company, you should be fired. Anyways, I'm going back to the terminal, making some changes again. Imagine that I fixed the vulnerability. I'm pushing it to Git. Remember, the only thing I can do is push changes to Git, nothing else. I have no access to the cluster. And Codefresh doesn't have access to my cluster either. So imagine that I fixed it, that I pushed change to the Git, and now this is executing yet another pipeline. We're going to be delayed a bit further than I thought. Anyways, going now back to my story. You're used to probably deploy applications by executing whichever commands you're executing to deploy stuff to your cluster. But I cannot do that. I cannot do that because of the self-imposed requirement, which I said at the very beginning. I don't want to have access to the cluster. I don't want you to have access to my cluster, and I don't want other tools, especially SaaS tools, to have access to my cluster. So the only way how I can deploy is by making changes to some Git repository that defines my production. There is a Git repository defines what is the desired state of my production. And if I want to change production by deploying a new release of this application, I need to change that code, that repository. And hence, this is why I have those steps on the right side. I am going to first clone the repository that defines production. Then I'm going to change the definition of the production by putting the tag of the image that I just built over there, and I will show you the repo in a few seconds. And then I'm going to push that change to newly created branch, and I'm going to create a pull request. The reason why I'm doing pull request at the end is because, as I said before, I'm doing continuous delivery, meaning everything automated except deployment to production, which requires human approval. If I would be doing continuous deployment, then I would push those changes to that repository without making a pull request. But in this case, pull request it is. Now, while this is building, let me open the repo and show you what I have here. So this is my production repository. This is a repository defines production, and right now it has no pull requests. And I will show you what production means by going to this directory, templates, and here it says, in the desired state of my production is to have Argo rollouts, DevOps Paradox, that's my demo application, DevOps Toolkit is the application I'm working on right now, and Prometheus. Normally this would be much bigger, right? But those are the desired states. And if I go here, you will see that right now, actually, that the definition of this specific application in production is a couple of things. First of all, it is a reference to a Git repository that has the base definition. Normally, the repository of the application says, basically, this is telling Argo CD, hey, you know what? Go to that repository and figure out from there what that application is. And when you figure it out, then override some values, some default values with values that are specific to production. In this case, I'm enabling Istio, I'm enabling horizontal pod auto scaling so that application scales automatically. I'm enabling progressive delivery, canary deployments in this case, and so on and so forth. So overwriting few values. Now, the important part here is now mentally remember that the tag is currently set to latest, which is a practice that you should never ever do. You should always be specific, but we're going to fix that. Right now, the tag is latest. Now, if I go back to pull requests and refresh, automatically a pull request appeared, right? That's my pipeline after building, testing, doing whatever it needs to do, creating a pull request for that would change the state of production. And now if I'm a person who has godlike permissions to approve change to production, I would go to Git, I would look at the changes. Now ignore there are many changes here because this is reformatting the same stuff. Nothing really changed. The only thing that matters is this line here, tag. The proposed change to production is to keep having this application, but instead of running whatever was running there before, to run the release 3AD6F13, whatever the release is, doesn't matter. It's actually commit hash. So there is a proposal through a pull request that production should change. And let's say that I reviewed that proposal and that I merge that to the master branch. By merging, I'm basically giving my approval to promote this specific release of the application to production. So I merged it. And so far, I'm not accessing Kubernetes cluster. Nobody is accessing Kubernetes cluster. Everything is Git-based. Cool. So now let me go back to the terminal and show you the Argo rollouts. Remember, I'm sending requests to my application that are returning errors. And by that, I'm simulating as if I just approved an application that is misbehaving. And we know that we will know that it is misbehaving by measuring, by querying metrics from Prometheus. So if I look at now what's going on, you can see that that a new release is progressing, right? Now it will be progressing now. Actually, let me go. I need to make this smaller so that you see it well. Okay. What matters here we, okay. Here we are, is that right now, only 10% of my users are seeing this new release. I'm reducing the blast radius and using that small percentage of my users to validate whether it's working correctly or no. And now if you remember the values that I showed you before, it will be on 10% for 10 minutes, for 2 minutes. And then when sufficient amount of metrics are collected with this new release, it will start evaluating. So now we have, I need to wait for 1 more minute approximately. And that means that you can watch me in silence. You can ask me questions. You have 50 seconds to ask me questions. Be fast, immediately. No? Okay. I'm sorry, I don't know how to sing. I cannot sing for you. I'm terrible at dancing, so that's out of the question. So we will need to wait in silence until we get to the next stage of, oh, really cool demo so far. What's up, Victor? Hey, Boris. What's up, Boris? Thank you, NG. Yeah, almost there. 15 seconds approximately. It takes a bit more than 2 minutes because first few seconds are the initialization phase. Come on, come on. Remember, I'm simulating error responses right now. Oh, I like the comment, Jörg. Your way of presenting closes all the gaps for questions. Thank you so much. Come on, almost there. It's taking longer. You know, it's fantastic how as time changes, I'm becoming more and more impatient. Before, if I had to wait full day until something is deployed, I would consider myself a happy person 15 years ago. Anyways, now you can see that first of all, the percentage of users who see the new release increased to 30%. You can see it here. And it started analysis. And you can see that 3 iterations of analysis were successful and 3 were failed. The successful ones were those that are measuring the response time, average response time. That's working fine. But those that are failing because those that are measuring the error rate, and error rate right now is higher than the threshold I set. So the system figured out that there is something wrong. I'm still not touching anything. And right now it degraded. What that means is that it is rolling back to the previous release. And right now, everything is being redirected back to the previous release, to what I was running before I made changes that ultimately resulted in a new release almost being deployed to production, right? Partially being deployed to production. And all that is canary deployments. You can even see the word canary here. So right now I'm still running the stable version, the one that is proven to work fine. And the canary release is scaled down. And look at me, not touching my keyboard. Anyways, what else? Now let's take a quick look at what would happen if I'm actually make a release that doesn't have errors. Again, I will simulate making a new release by saying I bet this will work this time. Git add git commit -m, do you trust me now? And pushing the change to Git. Now, while that is happening, I will go back to my, if I ever manage to, I will go back to my second terminal, and now I will start sending different types of requests, the request that will return 200, meaning that imagine that now I'm simulating that now users are not generating any errors. So it's kind of, not kind of, simulating success, that the release doesn't contain any negative effects. Now, if I go back to my pipeline, if I go to builds, and if I look at it now, it's the same process. It's always the same. That's why we like using machines instead of using people for this part of the process. Repeatable, always the same, effective. And if you're the person who is doing this manually, you automate everything, and then you can watch Netflix during your work hours, which is awesome. And the result is more positive, right? Better. I actually have a theory that most of the advancements in our industry are made by lazy people who just want to make things better so they can work less. Anyway, scanning the image. I already cloned the repository. I built binaries. I built a container image. And remember, you need to, especially since the recent news about, you need to start changing your vocabulary. It's not Docker image. It's not Docker image. It's container image. Docker is going away. Anyway, scanned it, cloned the production repository, redefined it. This is a simple script that is equivalent to set. Just changes the tag, pushes it back to the branch of the production repository, and soon it will create a pull request. And if I go back to my pull request, I should have none. Here you go, no pull requests. And then a second later, you see here is the branch was created, and now it will create a pull request, maybe. Come on. There we are. A pull request with another suggestion to change the state, the desired state of production. So this is, and I'm repeating this because it's important. It is not a suggestion to change production. It is a suggestion to change the definition of production. And then Argo CD in this case will do the changes. And I probably forgot to mention, Argo CD is important enabler in all this because it is a pull-based model. What that means is that Argo CD, actually, let me show you the pull request because it will take 2 minutes and then I have subject to talk. If I look at files changed, you can see that the only change is that this was run, this is the previous unsuccessful release. Now I want to run this one, whichever one it is. And I say, yes. No, I'm not going to write the comment. Just merge the pull request. And now nothing else. Now Argo CD will do the job. And the way how Argo CD does is that, and the reason why I don't need access to my cluster nor the tools is that Argo CD is running in my cluster and it is monitoring Git. So instead of me pushing instructions to my cluster itself is locked for incoming traffic. So because in this case, Argo CD is monitoring and fetching Git definitions and doing whatever needs to be done to converge the desired state, Git, into the actual state, which is the cluster. Anyways, where was I? Yes, now if I watch the progress here, the rollout, you can see here that the third release is ongoing. Remember the rule about 2 minutes before it starts evaluating. And right now, 10% is going to the third release, and 90% is going not to the previous one, but the one before that one, the last stable release that we know of. And then 2 minutes and some. Any questions? You don't have much time. So it's really, the trick is really to figure out when it is more appropriate to use push and when to use pull model. Like for my pipelines, there is push model is normally less resource demanding. It is more effective, and pipelines really do not need access to my production. So I was triggering my pipelines that do all the dance by using the push model, meaning that Git was pushing notifications to my pipelines in Codefresh that would do something. But for my cluster, pull model makes much more sense. So actually, Argo CD in this case is, I'm not pushing any changes to cluster because I don't have access. Argo CD is pulling changes in form of Git definitions stored in Git. Still sending 200, that's okay. Soon it will start analysis. And then, actually, to be honest, I'm surprised. Usually something fails by this time. I knew it. Something was bound to fail. It's inconclusive. What did I do wrong? Inconclusive usually means that there is not enough data to figure out whether to roll forward or roll back. Imagine that it worked. The moment I said something always failed, it started failing. So actually, no, it's now okay. It was inconclusive. We didn't have enough data. And now it is, let me see. Yes, now it is running the 6th. No, it's still inconclusive. It will eventually give up. But now imagine that this worked. Hopefully. Maybe. Yeah, it's definitely not having enough data. I'm missing something. Anyway, imagine that it worked and I would have a new release deployed to my production and all ready to go. What else? Let me see. Yes, let me show you actually Argo CD, people like that. And now that you get scared by looking at the terminal all the time, HTTP, I have it Argo CD ADDR, I think I have it here. Yes, so this is basically what is happening. These are all the applications I have defined in Git that are, in this case, associated with production. And the way how it knows that is this one that says production, that's the only one that actually matters. Oh, that's the only one that matters because that's the application of applications. Basically, that's the reference to the production cluster. And that application found out that is associated with production, which you cannot see here, I think. Where is it? Here, somewhere here. It's probably too small to see, but basically, this application is just a reference to the Git repository Argo CD production, where it finds all the other additional applications that are running there. And I have Argo rollouts, Devos Paradox, Devos Toolkit, and Prometheus. And Devos Toolkit is the one that we were using so far. And it shows all the status of all the different components and everything running for this application. And we can see that this is the previous analysis run, the one that failed. And then those in gray are the ones that are misbehaving right now for reasons which I don't want to debug now because we wouldn't have enough time. But imagine that the latest release was successful. It is running in production and we'll live happily ever after. And now we have, that's it. That's my quick demo, quick terminal, what's not showing you the full life cycle or part of it. I didn't show you pull requests, I didn't show you preview environments and many other things because I don't have enough time, but we have now time for questions. So do you have any questions? While you're thinking about questions, let me share screen one more time. Here we are. Yeah, there is a chaos. I don't remember the title anymore. It's mine, but Kubernetes Chaos Engineering with Viktor sometime in January. You go to Agile
February.
lectures and you find all the information, and you get there, and then we do stuff about chaos engineering. That's not a good commercial, I know, when you say you do stuff. It will be about chaos engineering, about doing something extremely satisfactory. And that means that destroying stuff and be rewarded for it. This might be your only opportunity in your career to be rewarded by destroying things in production, and all for a good cause. Anyway, questions. Now, you said there are a couple of them in the chat, right? Would be a good strategy to have diff duration times between hotfix branches compared to feature branches. I mean, to me, so when you're running in first of all, I don't think that Canary makes sense in my head only in production. And when you make changes to production, I don't really care whether it's a hotfix or big fix or whatever. The time is whatever the time is, and the time is whatever makes you comfortable to evaluate whether the experience your users have with the latest release is the correct one. Now, if you're confident that you need less time to evaluate metrics when deploying a hotfix instead of deploying something else, yes, you can change it. And that's why I had that Helm file with steps and durations. You can just say, okay, for this, and this is part of your commit. Among other things, the new tag is this, and the new set of steps are that. You just change it for specific release if you feel like it should be shorter or longer. That's absolutely not a problem. Is there a way to protect your cluster in case someone hacks into your Git repo? If somebody hacks into, so let's put it this way: if somebody hacks into you're pretty much doomed, right? That means Git repo. That means Artifactory, where you store your releases. That means your cluster. Now, what is, in my experience, easier? It's much easier to ensure and split things into different repositories and protect people like that, because among other things, you have full traceability, who did what and why and how and what's not. It's very easy to trace things through Git, much easier than if you give me kubectl access. If you hack into my Git, at least I will most likely know that you're there. If you manage to get access, like kubectl access to my kube API, then I'm in a much worse position. Then I will not even know that that you're there. Now, what you can do is like what I was doing. Hey, nobody can push changes to the master branch but me. And then another 15 people can propose changes and things like that. But ultimately, if somebody hacks into your source of truth, whatever that source of truth is, whether that's Git, whether that's directly cluster or what's not, you're lost. I mean, you're lost. You would need, in my case, you would need to revert to previous commit. Then Nireas, and if I butcher your names, that's not on purpose. I'm just terrible at pronouncing things. Nireas, with Argo CD, can you map any kind of hooks, checks, creation of new GitHub pull requests to any kind of actions, bash, kubectl, etcd, etc. For example, this could be trigger alerts that somebody hacked into a pod. Yes, but theoretically, if somebody, assuming that you're referring to, if somebody gets to your Git, he can actually change those triggers as well. Anybody else? I cannot bite. I was about to say I don't bite. I do sometimes, but we are online, so I cannot reach you. Don't be afraid.
Nope.
Hi, Victor. It's Paolo. So I have another question.
Sure.
So may I ask why you decided to use Argo rollout? And in case also, did you try Tecton and how would you compare them?
So Argo rollouts and Tekton are completely different. You can compare Tekton with Codefresh pipelines. Tekton is a tool to do pipelines. So if I would compare something with something, that would be Tekton with Codefresh pipelines. Now, I will not compare it for a simple reason. I promise to answer truthfully any single question except questions related to pipelines, for a simple reason, because if I say Tekton is bad for this and that, you will say that's because you work for Codefresh. And if I say Codefresh is worse than Tekton, then they will fire me. So I lose, no matter what I answer. But Tekton is comparable to Codefresh. They're both doing pipelines. What is comparable to Argo rollouts is Flagger from Waveworks. Both are doing progressive delivery. And then the third component I use today is Argo CD, which has the most horrible name in the history of names because it's not doing continuous delivery in any form of way. Argo CD is just doing the deployment part. This is what's in Git. That's what it should be in cluster. And Argo CD is comparable to Flux. Hopefully V2. Flux V is a horrible tool, but V2 is absolutely awesome. So Argo CD, Flux, Tekton, Codefresh, Argo rollouts, Flagger. Those would be competitors.
Great.
I'm old. I often forget the questions, so I start rambling things and forget what you asked. So if I did not answer what you asked, ask again.
Maybe again concerning tools, Viktor. There's a new tool every week.
Yes.
It's very difficult to catch up with what's going on. Any recommendations? Any way to approach this? When shall I stop picking new tools, looking for new tools?
No, you should never stop looking for new tools. That's our job, right? Kind of industry is moving fast. If we don't constantly evaluate better ways to do stuff through better tools, then we will be left behind. So the answer is never. Now, still, it is a real challenge because you realistically can evaluate only, first of all, you can spend only a fraction of your time evaluating because you have real job, whatever that is. Second, even if you would spend 100% of your time only figuring out new tools, you would still not be able to reach even a fraction of what there is because it's going so fast. So it's all really about the art of figuring out which one is worthwhile evaluating this week or this month or whatever, right? And it's I don't have the answer how, which one. I can go to my YouTube channel, let me post. You get a new tool every week.
I know. I know.
You know, okay, then no need to, okay, there you go. For the rest, here's the link now that I already copied it. But, and it's very, at least to me, it's very hard to find the balance. On one hand, you cannot spend your time trying to evaluate every single new project that was created last week, because that's insane. On the other hand, you cannot wait until everybody else adopts so that it's safe, because then it's too late.
Yeah.
And then it's somewhere in the middle, right? Kind of like if you would ask me, okay, service mesh, I would say, hey, go for Linkerd or Istio. There are others, but they have the biggest chance of becoming some kind of standard. So you pick one or two within the areas and hope that it will survive. But there is always a possibility of happening something similar to what happened to Docker. Everybody thought that Docker will be the thing, and now Docker is no more. I mean, there is Docker, but Docker is now something completely different than
for
what
something
people
different.
associated
Okay,
with. Yeah.
Understood. Yeah.
I can tell you, for example, that we in my previous company, we invested significant amount of engineering resources developing for approximately 3 years a solution based on the best possible container scheduler, which is Mesos. And then we said, and now to trash and start over. Those mistakes are very expensive.
Yeah, part of this of the way to install something new, to go for a new way technically should always be to look for what's coming next and what should be. That's totally true. And in a big company, and I'm in a very big company, we also have the demand for being consultative to projects. They ask for us and they want more like guidance. And so this is always very difficult. They want an ultimate decision and they want an ultimate consultation. And this is also very difficult to do. I know that, but it takes a lot of time until you have this this mindset that it'll never stop, right? That you never can really go for the next 5 or 10 years. You can always do what's best next and do not stop learning, right? And this is very difficult.
Exactly. And that's, I spend a lot of time in some form of consulting. And to me, the biggest challenge is that most of the time, what I'm consulting on or what people are really asking is not what they need, because people are usually concerned about the next week's needs.
Mm-hmm.
And the real deal is to try to figure out what will be happening a year from now, 2 years from now, 5 years from now, so that next week's changes are in line with where you're gonna be, even though nobody can know where you're gonna be a few years from now. It's kind of, that's a paradox. We don't know how the scene will look 2 years from now, but we need to figure out where it's going so that whatever you need to do next month is in line with that direction.
Yeah, no,
I'm
but
becoming
also
philosophical, sorry.
no, but this is important. But see, this is human to say, well, give me a break. Yeah, do not change everything every week, right? So tell me where we're going in 1 year, and then I have some time to go there. Do not, yeah. But this is so difficult. Really, really is. Totally different approach.
But still, I think it's very useful. You know, we obviously, especially in bigger companies, we cannot change things overnight or over a week or month or even a few years are often insufficient, right? But being able to paint some kind of vision, some kind of picture of where you could be. Like, let's say we should be doing canary deployments. I'm inventing the use case now. We know that you cannot use canary deployments anytime soon. Still, you should know about it, because the next steps which look unrelated to that should still somehow be aligned so that you're at least going in the same direction. So understanding that where Google is important for people to understand the reasons behind some short-sighted steps in a way.
Sure is. Yeah,
Victor, we have a couple more questions by Boris and Matteo.
Sure. Boris, can you explain in 2 words what happened while committed first time? Is it Snyk did? So the first time it failed because Snyk detected, I configured Snyk to fail or return non-zero exit code so that pipeline fails if there is medium or high vulnerability, and ignore low. And I tested it a few days ago, and the image that I was using, the code I was using in base image, did not have any medium and high vulnerability. So I assumed that for this webinar, it will work. But what happened is that new vulnerability was discovered and added to Snyk database between those 2 moments, a few days ago and now. So basically, there is a new vulnerability that didn't exist a few days ago, and Snyk detected it, and it was medium or high, I don't remember. Anyway, it made the pipeline fail. And this is important part about vulnerabilities. People think that, hey, I scanned something, therefore it's safe to run it in production, while the correct sentence is that I scanned something, it is likely safe to run in production right now, and we don't know whether it will be safe to run it tomorrow. And so usually we would, in case of Snyk, for example, we would, apart from you scanning when making changes, it would be validating your images and your clusters and everything periodically, let's say every hour, every day, and get back to you if situation changes, because it's a vulnerabilities databases are a living thing that change all the time. I'm not sure whether that answered your question, Boris. If you didn't, ask again. are you, so Matteo, Matteo something, sorry, Matteo, are you going to share the repository? Let me think, where do I have, I want to give you more than a repo. Oh, here, I'm going to share with you article instead of repo that has that same repo or similar repo, plus some written instructions and more detailed. I just put it in the comments in the chat. This is one of the blog posts I published maybe 2 weeks ago or something, December 7, well, like 10 days ago. It is similar material to what I presented today, but more explained.